Bismillahirrahmanirrahim. Assalamu alaikum dear students, welcome back in lecture 2. Student, basically we start manual and software analysis of a frame structure, and in lecture number 1 basically we just I just gave an intro of the structure, okay, and this is our structure. Basically you understand this, that okay, and I will explain the 2D frame system, okay, the plane of the building, okay, and now we will start our design, okay. So let's proceed to the lecture, okay. Let me show you what we have, okay. The data which is given to us is basically right here, where this one, okay. This is the given data. The clear headroom of the structure is basically 16 feet. Live load is 40 psf, okay. This is taken from the code, remember. This is already given, but if you don't have live load and you are designing a garage structure, or you are designing a mosque structure, so please visit the code. Our winter initial book, just introduction, chapter number 1st, I think so. In that McGregor MC Cormick book, you can choose these loads for various types of structure, okay. If you are going to design, you can choose these loads if these loads are absent, okay. So it depends upon the structure, clear. For a school structure, round about 60 to 50 feet load is taking, okay. These are the finishing, okay, that is specified. You have to apply a 1.5 inch thick and 3 inch mud, okay. 1.5 inch thick means you have to provide a marble, or you have to provide any such kind of arrangement, okay. So we have 3 inch mud, okay. This is the kind of finishing which is provided to the top, okay. Remember, here we are basically analyzing the structure for one story. If you are analyzing the structure for second story, third story, then we have to consider the first floor. Remember, we have to consider that as a first floor, and in that case we don't need to consider this 3 inch mud, okay, because on the floor we do not provide mud. Mud is basically provided on the top, or you can say on the roof, okay. So once we are designing this the second story structure like this one, so in that case here we have a floor at that level, at first level, and at the second level we have a roof. So on the roof we will consider mud, but on the first floor we don't consider that mud, okay. So you must make sure, okay. And 1.5 inch thick, there may be marble, there may be chips, mosaic, any kind of flooring, okay. Remember, on the roof we are basically providing marble or chips. Different options are available, okay. And allowable bearing capacity, this is 2000 psf. You have to determine this by SFT or any other tests, okay. But basically it is provided by the geological or geotechnical engineer, okay, this bearing capacity. Or you can, if you are designing a structure in any locality, so you can determine that bearing capacity from any other local studies or local charts, okay, which will be available, okay, or any other structure which is constructed in the locality, okay. So depth of the footing below ground level is 4 feet, assume 4 feet, 3 feet, 5 feet, we almost assume this, okay. And FC frame, this is a strength of concrete 4 ksi and 60 ksi. Already you have to specify these things, okay. Almost we specify FC frame 3 ksi, because 3 ksi strength in our locality, basically it is possible to achieve. 4 ksi is a high strength, okay, and it is not easy to achieve for local, because you have to consider the way of construction, whether they are order the concrete from external sources, or whether they are producing concrete at their own site. So 4 ksi strength of the concrete is not easy to achieve, okay, on local level of work, okay. This need basically factory production concrete, okay. So you have to consider. And 60 ksi you need to look to the market. 60 ksi and 40 ksi steel is available. Okay, so what we have to do, we have analyze and design the slabs panels A, B, C. We have to analyze and design beams B1, B2. We have to design columns, we have to design footing, we have to design staircase. Clear? So let's see the design. Okay, and then we coming back. Okay, so we have panel A. Okay, we have panel B. Clear? We have panel B and we have panel C. Remember, we have two panels, and remember the edges of this panel, these edges are discontinued. These three edges are discontinued, but this edge is continuous. Remember, this edge is continuous. Okay, similarly in B panel, this side of the panel is continued and this side of the panel is continued. Clear? Similarly in C, all sides are continued. In panel C, all sides are continued. So you must understand which side is continued and which side is discontinued. Remember, you have to find out which one is the shorter span and which one is the longer span. So remember, shorter span is denoted by LA, I think so, LA, and the longer span is denoted by LB, but these are the clear span. Okay, so let me check. Here we have, okay, let I show you. Okay, these are the data I already explained, and this is our grid system. Okay, so you see that we have panel A, panel B and panel C. Remember, these are the clear distances. Remember, 19.437 and 18.87. Okay, these are the clear spans. So let us see that whether, remember, the grid spacing is 20 by 20 feet. Remember, 20 feet, and here you see 20 by 20 feet. Remember, the total span is 100 feet and 100 feet. Remember, now let us check the dimensions of panel A. Remember, here you see we have a beam at one side of the panel A. Okay, and in panel B we have two side beams and two side we have masonry wall. Remember, now to find out the dimension, the clear dimension of panel A, you see here, remember that here we are assuming that we are using 12-inch wide beam. Remember, this is assumed. Clear? This is assumed. This is totally assumed. Remember, 12-inch. Now, so due to that, you see here this is 12-inch wide beam, and these are the dimensions: 18 feet 11.3 inches. If you convert 11.3 inches divided by 12, you got 9.3 or 9.4. Okay, similarly 10.4, if you divide this by 12, you got 87 something. So 18.87 and 18.93 something, and here you see the dimensions are 19.4. remember, this is 18 point because this dimension is basically from the center line of the beam, not from the face. Okay, we have to consider it from the face. So from the face of the beam, you can say the clear distance is 18.93 something. Okay, and this in this direction 18 point. So remember, this is our longer dimension LB. Okay, and this is our shorter dimension LA. Clear? So here you see this is more than this one. Okay, and the wall thickness is 1 feet, you can say 13.5 inch. Clear? So that's why here you see LA is 18.875 and LB is 18.93. remember, from where these dimensions comes, you see the calculation here. 20 feet is the center to center distance 2 times of 13.5, because you see here that we have this wall and we have this wall. Okay, so you have to subtract 13.5 from this wall and 13.5 from this wall. Okay, so that's why you got the clear distance 18.87. Clear? And 20.20 minus 13.5 divided by this one and this one, this is basically beam width. Okay, and this is your wall. Okay, so you see here, this is the wall and this is the beam. This is 12 divided by, and remember this is the clear span. So here you can see they basically use 2. So this 2, I think so, this 2 is nothing, is not absent, is absent. Okay, you doesn't count for this. Okay, then you got 18.93. if you multiply 2, then you will got, I think so, 19. Clear? Then you got 19. Clear? So please make this point clear. Okay, from the AutoCAD you see here the clear spacing is 18.93. Okay, so these are the dimensions of panel A. Now let's move toward panel B. You see here in panel B, 2 sides are continued. One is longer side and one is shorter side, but remember the shorter and longer side both are same, both are equal. Okay, this is interesting. This is a square panel, remember. And you see here that from the face of the beam to the face of the wall, this is 18.93, and from the face of the wall, from the face of the beam to the face of the wall is 18.93. Sorry. And if we coming toward panel C, you see here panel C clear spacing is 19 feet from the face of the wall to the face of the beam to the face of the beam, other beam. And similarly in that direction, if I show you, let me show you from this point to this point here, let me show you, that is also 19. So panel C is 19 by 19, panel B is also a square panel 18, and this one is LALB. Okay, so I think so these dimensions are clear. Let's proceed. Now we have to determine the thickness of the slab. Remember, we have to determine the thickness of the slab. As this is a two-way slab system, remember these are the two-way slab system, because almost shorter and longer dimensions are same. So therefore if you divide LB by longer side divided by shorter side, LB by LA, you got the ratio will be less than 1, less than 2. So students, one thing you must make sure that this calculations here, remember this is okay. Remember this is okay. Clear? This is 18.93 is okay, because if you come here and you search this one, remember that from center of, in case of panel A, from the center to center distance is 20 feet, and this is 12 inches beam. Remember, 12 inches beam. So the clear spacing will be how much? This is the clear spacing, remember. So from 20 you have to subtract this half of 13.5 and this half of 12 inches. Okay, so that's why this calculation is okay. So please make correction for this. Okay, so proceeding forward, because as we are discussing the two-way slab system, so we have a two-way slab system, and a two-way slab system basically the thickness of the slab is determined by the parameter divided by 180 into 12. Remember, into 12. So we have to check panel A, B, C as well, but as panel C dimensions are more, so therefore we just only check the thickness on the basis of panel C. Remember, this is very important point. Clear? Not for the lower one, we have to check it for the longer one. Okay, so we got basically 5.067 inches, therefore they use 5.5. remember, go for higher values, not just say 5 inch. You have to use 5.5 or 6 inch. Okay, minimum 6 inch thickness is specified. Remember, this design is basically on the basis of 1995 code. Remember, 1995 code, and nowadays basically in the recent edition of the ACI, they recommend that the thickness of the slab should not be less than or equals to 6 inch, remember. But here I am using 5.5 inch. The best approach is that you will use 6 inch. Okay, so please make sure that you don't need to use thickness less than 6 inches, remember, for two-way slabs, for two-way or one-way slab system, remember. Okay, so you find out this point. Okay, this is very important. We have dead load, remember. We have tile 1.5 inch. I already explained this. So here we are using the tile density is 110, remember. Tile density, this tile may be a marble tile, this may be chips tile, mosaic, any material, any tiles. Okay, so their density is 110, or you can say 0.11 kip per square feet, remember. So thickness divided by 12 multiplied by this one. This is the way we have to use mud, and the mud density is 100 psf. So divided that 100 by 1000, you got kip per square feet. So that's why you got this one. And we have 5.5 inch thick slab, so that's why you have to multiply density of concrete, and you got this one. So this is basically your total dead load, this one, total dead load. And the live load, which is already given, is 0.04 kip per square feet, remember. Total service loads, so dead load plus live load, we need service load, remember. In design, basically when we are designing column, footing, we need service load. So that's why step-wise you have to calculate service loads, then we need to factor the loads. And remember, this is 1.7 live load, 1.4 dead load. I already mentioned that this is basically this design on the basis of 1995 code, ACI code. Okay, so after 2000 ACI code, these factors are modified, and this factor is 1.6 and this factor is 1.2. Although this is more conservative approach, okay, you can use this. Okay, this is a little bit economical approach, remember. But this is not, you can say, a bigger mistake. Okay, it is a conservative approach. If you are using 1.7 and 1.4, this is not a mistake. Okay, so the total factor, the total service load is this one, the total factor load is this one, remember. Now we need to find out 1.4 dead load. This is total factor dead load, and this is total factor live load.